Good morning. This is Mike Human of G2M Research, and welcome to our webinar sponsored by Pliops. This is the Pliops XDP-RAIDplus webinar, introducing the best data protection solution for NVMe and NVMe over fabric environments. Let me kind of walk you through the agenda and the ground rules. So from an agenda standpoint, I'll do a quick slide talking about why accelerated data protection is important. Then we'll turn it over to Tony Afshari from Pliops. He'll talk for about 15 minutes. After that, we'll follow up by Tom Sanfilippo. Tom is an actual user of the Pliops solution. It's at Paperspace. He's the CTO there. And then we'll also turn it over after that to Yu-Yang Sun. She is with Solidigm. We'll have a panel discussion after that. There's a couple questions that we'll go through. And then we'll also do the Q&A and wrap up. So quickly going through that. If you have questions, please use the Zoom Q&A window. We'll hit all the questions at the end. We're also going to have 3 audience survey questions. Those will pop up in the Zoom poll window. The answers are anonymous, so you don't have to worry about what you put down. I won't know what you put down. Tony won't know what you put down. Nobody will. So please participate in those if you can. And with that, let's go ahead and get started. And one other thing, we are recording this webinar. We will give everybody a link to the recording. It'll come out probably 2 days after the webinar. So I think Thursday timeframe. We'll also send everybody that's registered a copy of the slide deck in PDF format. So with that, let me go ahead and get started. So the question that we're trying to answer is, why is hardware RAID protection important today for data resiliency? Now, if you think about it, 15 years ago, if you think of the data centers, CPU efficiency was a big issue. Most CPUs were significantly underutilized, which meant all the I/O and other pieces that went along with them weren't. And the problem generally was performance of the compute side of things. Once VMware came out and some of the other tools like that, that really changed. Machine virtualization meant that you could pretty much get your CPU utilization close to 100%. At that point, then the rotating media that we had in storage was the big bottleneck. Storage was significantly slower than CPUs could go. Luckily, that got solved about 7 or 8 years ago with NVMe and then NVMe over Fabric. We're at the point now where storage is significantly faster in many cases than the CPUs it's attached to. So today, what's the problem? It's really the data processing that goes on at a high level. In other words, if you think about networking, level 3, level 4 sort of processing, if you think about it in terms of storage, rebuilds and things like that, and data protection are big issues. Same with snapshots and issues like that. Those are the big issues that we see today. And that's why you see a lot of people in this industry, especially in hyperscalers, building acceleration products around these things, whether it's networking or storage, very high-end products that actually accelerate that higher level work to to get rid of that bottleneck. Hyperscalers, like I said, have heavily invested in this technology. They're putting a lot of money into it. So the question is, how can non-hyperscaler companies get the same benefits? And that's why we're here talking with Pliops today. So let me, with that, introduce the panelists for our webinar. We have with us from Pliops, Tony Afshari. Tony is the Vice President of Products and Marketing. From Paperspace, we have Tom Sanfilippo. Tom is the CTO at Paperspace. From Solidigm, we have Yu-Yang Sun. She's a Product Marketing Manager. And then I'm Mike Human. I'm the Principal Analyst for Storage and Compute at G2M. And with that, Tony, let me turn it over to you. Let me give you remote control. You should have it right now.
Okay, great. Let's see if it works. Click once more. All right. Thank you very much for attending the webinar today, and thanks to our host, G2M Research, for making the webinar happen. Also, many thanks to our partners, Paperspace and Solidigm, to partake in the webinar with us today. First, a bit about Pliops Extreme Data Processor, or XDP for short, and data services that run on that platform. our XDP processor is a very innovative data shaping engine, essentially. It combines multiple data and storage technologies into one device. And at the core of it, it uses breakthrough data structures and algorithms to eliminate the inefficiencies of software-based solutions to deliver gains in performance, reliability, capacity, and efficiency. I must say that XDP also frees the host CPU to focus on other high priority tasks, and you'll see how this benefits in RAIDplus. So we are offering 3 great data services on top of the XDP platform, and even more will come in the future, of course. We'll cover XDP-RAIDplus in depth, but wanted to also quickly mention the other ones. Pliops XDP data, XLDB data service. This is the best-in-class database accelerator for SQL applications such as MySQL, MariaDB, Postgres, but it also accelerates NoSQL applications, including Mongo and software-defined storage. Specifically, it accelerates database loading, OLTP, backup, and analytics operations. And as an example, a leading customer is showing north of 3x improvement in their transaction processing while improving their TCO by 54%. Pliops XDB XLKV data service is the best-in-class key-value accelerator solution for storage engines such as RocksDB, WiredTiger, and other NoSQL storage engines. Being a native hardware key-value accelerator, it provides an order of magnitude higher performance and lower latency than software-only solutions. As an example, one of our customers that is deploying the XLKV solution with XDP Rocks library, which is a binary compatible library with RocksDB, 7x more system efficiency, so 7x more throughput out of their infrastructure. And another customer who's using KV Rocks powered by our XLKV product is seeing 30x reduction in tail latency. I left a link at the bottom, pliops.com/products, for you guys to take a look there. But I also want to mention our partner, PhoenixNAP. PhoenixNAP is a very innovative cloud provider, solution provider. They also have instances that are powered by XDP, by Pliops XDP. So they're offering those to their customers, but as a trial, you can also go and visit the link on the pliops.com/products and go land on that site and enjoy the trial that is provided by PhoenixNAP. A little bit more about RAIDplus. As you're aware, and Mike mentioned this, data protection without performance penalty is highly critical for the design and deployment of business applications. Traditional protection technologies such as RAID have not evolved fast enough to meet the needs of our customers and the application performance, scalability, and reliability. And you can say that the NVMe SSDs continue to get faster and denser, so they're getting better. But traditional RAID technologies that are managing these SSDs are bottlenecking the performance capabilities of these drives. This has led to business moving away essentially from traditional RAID deployments. They're very hesitant to put something like this with these good, awesome drives that our friends at Solidane will talk about. XDP-RAIDplus is a best-in-class data protection service for SSD environments, including NVMe and NVMe over Fabric. But of course, the solution works with any SSDs, including SATA and SAS as well. We designed this product from ground up to provide extremely reliable RAID data protection, but really without any associated performance penalty. It unlocks the full performance potential of SSDs by eliminating inefficient storage operations and offloading compute-intensive data processing activities away from the CPU. RAIDplus uses a distributed RAID algorithm, and thus no single drive is reserved for parity, and the same technique is used also for spare capacity, so we don't have a dedicated drive for parity or a dedicated drive for spare. And unlike traditional RAID, which uses a dedicated hot spare disk, RAIDplus makes use of all SSDs with what a feature we call virtual hot capacity to drive performance and capacity benefits. So you get full uptime and full performance with protection for multiple single failures in this model. We'll talk about this a little bit later. All data and metadata is protected against sudden power down failure using onboard NVRAM. So data on flight is absolutely protected, unlike some of the other solutions out there. It also features a rapid recovery with a very fast rebuild. That is because we only build data that is stored, not the entire drive. And I'll explain that a little bit more. So I want to walk through some important pillars and show how we differentiate with solutions that are available out there, with the leading solutions out there. So we worked with a third-party entity to do some performance evaluation versus the leading brand out there. As you can see, the comparison versus MegaRAID is significant, 12x better in normal operations and 23x better during a rebuild. As you know, traditional hardware RAID with parity-based RAID algorithms uses small random writes, which significantly impact performance. And also updating the stripe requires reading existing data and parity blocks, comparing new parity, and finally writing new data and parity. This process is called read-modified write operation. And Pliops XDP-RAIDplus accelerates random writes by transforming them into compressed sequential writes, which improves storage performance, utilization, and SSD longevity. You can see the read numbers are also great. Even though we are just directly moving data from SSD to the host. Why is that? Well, compression shrinks the amount of data that to be read, and this enables better read throughput and latency while reducing amplification impacts. So great performance off the bat. Let's talk about fast rebuild times. So application performance and quality of service are obviously equally critical as reliability and data protection during SSD failures. As you know, quality of service is plays a vital role in our customers' experience and satisfactions, especially during storage outages. Those could be very costly to our customers, to everybody's business. While a drive fail, when a drive fails, a traditional hardware RAID 5 system performs very low and what we call severely degraded. And this can significantly impact the application quality of service and customer satisfaction. All of this translates to essentially what business you can get out of that system for your customers and for your transaction. Secondly, when an SSD rebuild is initiated with a hardware RAID solution like MegaRAID, the entire SSD capacity of the failed drive is rebuilt on a spare drive using data and parity blocks from the remaining drives. This leads to a very slow rebuild and continued performance impact. This can put your data at risk, and as the probability of another drive failure is increased during the rebuild process, that the problem can get bigger. So the longer the rebuild, the possible higher probability of having another drive failure. So the quicker you can do that, the probability of the second failure goes away. And that's the nice thing about a solution like ours. We see customers trying to address this, of course, by using lower capacity SSDs. Sometimes they're forced to use lower capacity SSDs. And as you know, that limits storage density, raises the effective cost per terabyte value, and it has a direct impact to the TCO. But RAIDplus accelerates rebuilds by only rebuilding user data that is impacted in a drive failure, and not the entire SSD capacity. And this results in ultra-fast rebuilds with minimal impact on performance and quality of service. Here's the third-party performance measurements that are showing XDP can rebuild at a rate of 7 minutes per terabyte, which is 5x faster than MegaRAID. And the net result is that the user application impacts is minimized. The speed of XDP-RAIDplus during a rebuild also removes the risk and anxiety of putting high-capacity SSDs in, making it easier to keep up with the ongoing data growth and lowering the cost per terabyte of the data storage. The next thing I wanted to tell you about is the SSD drive life. So when we talk to our customers, they all tell us that NAND flash can be the costliest storage component with TCO direct link to SSD costs. As a result, they have a vested interest in maximizing SSD lifespan. As you know, SSD endurance is typically stated in drive writes per day and represents a total amount of data an SSD can write over its lifetime. As previously discussed, traditional RAID 5 processes like MegaRAID trigger a read modified write process and garbage collection operations that significantly contribute to I/O amplification. So more write amplification, more read amplification, more space amplification, which itself contributes to wearing the drive and can lead to over provisioning and further shortening life of the SSD. XDP-RAIDplus adds important value to both TLC and QLC SSDs by dramatically reducing the write amplification. This is something that is key to our technology, and it comes as a result of us being able to shape the data for optimal placement on SSDs. Here we are showing how XDP-RAIDplus improves the SSD endurance by 5x versus MegaRAID for TLC SSDs and up to 18x for QLC SSDs. As a matter of fact, XDP-RAIDplus practically increases the endurance of QLC beyond traditional TLC. So we have customers that are feeling very comfortable putting in QLC drives with XDP, and you're seeing the results of TLC performance while benefiting the economics of QLC. Finally, I wanted to talk to you about optimized capacity and usage savings. So you know that data protection benefits RAID 5 and RAID 10, but so those are great schemes to protect your data, but they come with a very unfavorable storage capacity loss due to parity or mirroring overhead, essentially. For RAID 5, parity consumes the capacity of an entire drive, and typically another for a hot spare. And RAID 10 obviously uses 50% of the total capacity in mirroring. Obviously, data protection methods such as compression could improve utilization by storing fewer bits, but consume significant CPU resources, essentially overshadowing their benefits. We hear this from our customers all the time. Our XDP processor implements multiple parallel compression engines. These will compress indiscriminately. Doesn't matter. There's no API required. It's just going to squeeze in as many bits as it can. And this prevents essentially the bottlenecks that we talked about and frees up the CPU from its burdens. We're seeing that XDP's compression capacity, capability, efficient protection overhead, and near full utilization, 95% in this case, expand usable capacity by up to 6x versus traditional RAID solutions. This 6x increase is usable capacity, in usable capacity is substantially reducing the cost per terabyte formula for our customers. And our customers are seeing that their multiple petabyte when they're deploying multiple petabytes of storage, this increased capacity is translating to millions of dollars in savings. So as you scale, as you put more servers, more data centers, more racks, the number just increases. And so the thoroughly enjoy this and benefit from it. In summary, this is just some of the factors that people take into considerations when they're choosing a data protection scheme. So, sorry, I went too far. Let me go back. I don't know if I can go back. Nope. Okay, I can go back. Sorry about that. So performance acceleration, data protection, SSD endurance, capacity expansion and TCO benefits, legacy and modern application support, ultra fast rebuild. These are all factors that we see customers are taking into consideration, and XDP-RAIDplus gets very positive benefits and feedback from our customers across all these categories. As you can see, software RAID or traditional RAID solutions address some of that, but nothing across the board. And then finally, why are people migrating to XDP-RAIDplus? We have many customers that are using RAID 10 solutions with their databases, but essentially they're killing half their capacity. Hardware RAID 5 solutions like MegaRAID have performance and capacity issues that XDP-RAID addresses. And even RAID 0 has data integrity issues. Even if you go to cluster mode and doing rebuilds across a cluster and set up your local drives in RAID 0, drive failures still cause big problems and increase the east-west traffic for rebuild, expand the glass radius. So people are hesitant to put greater than 8 terabyte drives, even with RAID 0, which XDP-RAIDplus addresses. And results are capacity expansion, TCO savings, better dollar per terabyte savings, and higher SSD endurance. Thank you.
Thank you very much, Tony. We have one audience survey question that we're going to launch right now, and we'll do that while we move on to Tom. So let me launch that quickly for everybody. The question that you'll be seeing is how critical is it to address drive failure and rebuild for your business operations? We'll give you about 2 minutes to answer it. It should be up on your screen. Just go ahead and click the single answer that makes sense. And with that, let me turn it over to Tom Sanfilippo. Tom is the Chief Technology Officer at Paperspace.
Hi, I've been with Paperspace for about 6 years. We're a GPU cloud service provider targeting AI and GPU accelerated applications. We also are now, working with alternative accelerators besides the NVIDIA accelerator, like the GraphCore IPU accelerator. We're in multiple regions throughout the world. We have about 3.5 petabyte of active storage, and this is almost all for our customers. So we don't really have a view into their data. They bring the data in and put it in their virtual machines and in their data stores to use our accelerated compute. The way we've organized that storage, we've got about 90 NFS-based servers running open source NFS with all flash storage in them. Each of those servers has traditionally had about 22 PCIe or SATA SSD drives, I should say, SATA SSD drives, and a large network interface. We have had to use RAID technology with that storage since we put it into production, and we based our SATA SSD RAID based on a product from Broadcom, Megatrends. I think it may be the Mega RAID card that Pliops evaluated. That card, in fact, is availability constrained for us. We've had difficulty getting that card over the last year to replace older units in whole, or to add the old traditional SATA SSD storage units to our network. We experience drive failures on a weekly basis, even with SATA SSD drives, given the large number of drives we have in our environment. And we have long recovery times on those drives, typically around 5 hours. And we have performance degradation, although that we have significant performance degradation while those drive rebuilds are going on. We also, this is an NFS-based remote storage architecture for our virtual machines, and it has some networking overhead and some driver overhead in the hypervisor layer, and we get a relatively low throughput with these SATA-based arrays of around 250 megabits per second or megabytes per second across our network infrastructure. So we also fill these up very quickly. We can actually fill up a 40 terabyte NAS unit in about a day to 2 days. So we're constantly adding new devices, new NAS units, usually 4 at a time, but sometimes we get in a crunch and we've got to add more. So we identified a bunch of needs last year. We needed to start adding storage in bigger increments, so we weren't always rebalancing storage. That's the way we get around some of these storage crunch issues, is we often rebalance storage units that are lightly used, where customers might age out over time. We can move new users over to those storage units over time. So we needed to start buying our storage in bigger increments, and that meant we were going to have to increase the number of NASs we were buying. We knew that this was not competitive for our platform. We knew that our users needed faster storage. 250 megabytes per second is not really viable for many AI applications. So we needed NVMe-like speeds for our NAS architecture. And we needed faster recovery times, higher density. One of the goals we didn't have was making it cheaper. We wanted the faster performance and faster recoverability, but we weren't trying to optimize for costs. We were going to see where we came out on cost. So we settled on a solution built around the Pliops XDP card, and using 8 15 terabyte Solidigm QLC drives. And we kept the same network interface in those storage units, but we also added a 100 gig storage network as well, because this system designed around the Pliops card and these NVMe drives could push beyond 40 gigabits per second on the NAS interface. The results of this design, it gave us 8x storage density improvement, because we were able to go down to a 1U chassis instead of a 2U chassis, and the number of individual drives was reduced and their capacity was increased. We've seen a 2x speed up in recovery time improvement without, we've seen the same benchmarks that Pliops has posted in terms of the behavior of recovery, in terms of its impact on regular data access and its speed. So that has been great. We haven't had a real drive failure since we put this in production for these NVMe drives, because these are relatively new. It's been, I think, it's been in production about 6 months now. So we don't have a real experience with that, but in our lab testing, we saw this improvement. The throughput is about, this is the end-to-end performance improvement, throughput improvement has been about 5x. We're up around beyond a gigabyte per second over our network infrastructure. And now we're network limited, essentially. So we need to upgrade our network paths to some of our compute hosts to take full advantage of these new NASs. And one of the big outcomes of this is it was actually cheaper. It made it an easy call for us. By utilizing these larger NVMe drives, using the QLC technology and being confident that that was not going to be a risk for us, the cost per terabyte is actually about 33% less than our old SATA SSD NAS units. And some other parts of the experience, the Pliops technical support has been outstanding for us. Whenever we've encountered a technical issue, they've jumped right on it and helped us to dig through those issues. It's been terrific. And then I had one of my storage engineers working with this, initially reading through the documentation, and he's like, I don't think this is ever going to work. And then a week later, he was like, this is amazing. The performance is incredible. So it went over my technical team as well. So that was a great experience. Thank you, Pliops.
Thank you very much, Tom. Let me next turn it over to Yu Yang Sun is a product marketing manager at Solidigm. Yu Yang, you ready to go?
All right, thanks, Michael. Hi, my name is Yu Yang. I am from Solidigm. I manage the QLC SSD product at Solidigm. And today, thanks for the invitation of Pliops. I'm happy to be here to introduce Solidigm's QLC SSD and also how XDP, provide the data protection for the high density SSDs without a compromise to the performance. So for those who don't know about Solidigm, I'd like to introduce a little bit of our company. We formed in late 2021 when SK Hynix purchased Intel's NAND SSD business. So we combine our NAND technology, our manufacturing capability, decades of SSD development experience, and also all the expertise to serve our customers. Right now, we headquartered in San Jose, California. We have nearly 2,000 employees, and we have 20 locations across the globe. So we are really, really big startup. So today we'll talk about QLC SSD mostly. If you look at the slide, this is a survey we've done, internally and externally across the industry about what's the biggest storage pinpoints in the data center. You can see we have aging gear, we have lack of capacity and high cost. And QLC SSD is developed to address all these pinpoints. For the aging gear, 85 to 90% of data center right now, data is still stored in hard drive. And as hard drive is slow. Even though the dollar per gigabyte cost is lower, it just cannot scale as fast as a lot of data center demands it to be. And in the data center, the data structure change, more and more data is moving from the core to the edge. It demands more capabilities of being able to access data fast, being able to scale fast, and also have more sensitivity towards the power, the cooling, and the scalability, and also the weights and all those kind of things that hard disk drive is having a hard time to provide. Secondly is on the lack of capacity in the data center, right? Actually, in nowadays, the customers is providing a lot of data-rich services, and we have the 5G high-speed networks, and we just have a lot of more data than decades ago. And a lot of applications such as AI, machine learning, big data, they need a lot of data, and they need to be able to access those data fast so that they can process it. So we see, one of the challenges as lack of capacity in the data center. And lastly, on the cost, SSD spending grows 4.5x faster than compute. And also the legacy storage drives, the hardest HDD specifically, requires a higher TCO, and it also have a higher cost to maintain those gears, together with what we mentioned earlier, the lack of scalability, and it just casts a higher cost to the modern data center. So QLC SSD is developed to address all these key storage pinpoints. Next slide. So as you can see here, QLC allows a data center to have rapid access to more data with more efficiency. Whether it is random or sequential, whether it's the smaller blocks or large blocks. This is a test done by Storage Review. You can see that QLC SSDs almost offers the same level of performance of the TLC SSD, which is the most common SSD technology, NAND technology used in the data center. It's able to give you as high as hundreds of gigabytes of second bandwidth with pretty good, very impressive cost savings. As mentioned earlier by Tom, it's about like 20 to 30% lower cost than the mainstream TLC SSDs. Next slide, please. So this is a closer look at the performance of the next generation of QLC SSD. As you can see, traditionally, we assume TLC have a better performance because it has a higher cost and it has less bits per cell, so it should have provided better performance. But you can see here, when we compare the 4K random write performance of QLC with our comp TLC, it gives a 24% higher throughput and also a 20% better latency compared to the entry-level TLC. And also, when compared to the QLC, the difference is much bigger. Thanks to the floating gate technology used by Solidan, we are able to give a much better throughput and latency than comp's QLC. So not all QLC are created equal. The floating gate QLC by Solidan is simply much better in terms of performance and endurance as well. Next slide. So this is just another example of the performance on the 64 KB random read performance. Again, similar to the last slide, you can see at QLC SSD, the floating gate QLC SSD gave a much better throughput and latency performance for the 64K random read than comp's TLC and comp QLC SSDs. Next slide. So I'd like to introduce you to the next generation of Solidan QLC SSD. For this slide, you can see that for the next generation QLC, capacity-wise, we offer up to 61.44 terabyte of density. And the lower range will be 3.84 terabyte. And also QLC SSD gives you a endurance of up to 65 PBW. That means you can write randomly to the drive over the lifetime of the SSD of 65 petabytes of data. That's actually a lot of data, and that's like ample endurance for a lot of use cases. And for the form factors, we also give offers a wide range of form factors, ranging from E1.S, E3.S, U.2, and E1.L. So I just want to go back to the capacity a little bit to give you a perspective of what does 61.44 terabyte means. When you think about a standard 2U server with 24 drive base, that means you can get up to 1.4 petabyte per 2U with that level of drive density. So that is huge. And that is where XDP comes into play and provide, the data protection for, concerns about the blast radius. Next slide, please. So this is a test done on a Dell PowerEdge with 4 30 terabyte QLC SSD. You can see that XDP together with QLC give you, with 4 QLC SSD give you a 47 gigabyte per second of sequential read performance, and a 6 gigabyte per second of sequential write performance. As Tony mentioned earlier, right, data protection and drive rebuild time is very critical, because you don't want the drive to fail during rebuild. Traditionally, when you have HDD, it takes days for data to rebuild when there's drive failure. But with XDP and QLC SSD, you can shrink that time to as little as a few hours. That's very, very important to increase the robustness and reliability of your data. Next slide, please. This is just another example where XDP improved the performance on the random, right? You can see the mixed random and also the 16K random read and writes. XDP together with QLC provides a better performance than a traditional software read 0. And with this level of performance, customers is able to get much better, performance for the sub-IU, like the smaller read and writes on a large density QLC SSD. That's all I have.
Thank you, Yang. That was excellent. I definitely like the little dinosaur in your QLC QRC codes.
Oh, that's a good reminder. So if you're interested to learn more about, Solidigm data center SSD, you can scan the QR code at the top. And we also have 2 nice papers on the how QLC and XDP combine to provide better performance and endurance. You can scan the QR code at the bottom to learn more about those. Excellent.
All right, we're going to go to the panel discussion. Before we start that, we're going to launch our second audience survey. The question is how critical is it to address blast radius concerns when deploying SSDs that are greater than 8 terabytes of capacity? Let me go ahead and launch that. And while we go through that, we'll go to the first panel question. First panel question, we'll start with you on this, and then go to Tom and then Tony. Again, on blast radius, the blast radius problem for high capacity SSDs is still a concern for many companies. Is the blast radius problem really a capacity issue problem? Is it a rebuild time issue problem, a wear issue problem, or something else?
So yeah, as I mentioned earlier, I think blast radius, well, it's a combination of all of these, right? You know, it's as the SSD or at the storage device density getting bigger and bigger. You know, if you know, first of all, you know, drive fail is inevitable, and as a data center, you know, architect, you have to take that into consideration when you build your system. And when there's and also the second thing is the trend, right? We need more and more data. We need to store more and more data. And how do you store more and more data more efficiently is to have higher density drives. And QLC SSD provides you that higher density. We can go, you know, right now we can provide a 30 terabyte per drive, and the next generation we go up to 60 terabyte. So this is a trend, and you know, there's nothing, you cannot go against trend. As you know, you just need to have bigger density to have more cost efficiency, and also, you know, to store more data. And the next thing is, how do we address this, right? With higher density drives, how do we handle drive failure? And you know, and I think what is listed here is very you know, it's the answer in the question, which is to have a better rebuild time whenever there's a drive failure. You know, we want to have this drive recover as fast as possible. XDP gave you the capability to, you know, recalculate all the parity in a fast speed, and SSD allows you, especially, you know, NVMe QLC SSD allows you to read and write the data fast, so that you can rebuild those data very fast. So that's, I think, so that's my answer to the blast radius problem, which is to have a better capability to address the drive failure by having a shorter rebuild time and a stronger data protection mechanism.
Excellent. Tom, I know you guys have about 1,000 drives in your systems today. What are your thoughts on this?
Yeah, the blast radius issue. Yeah, it's a constant concern, and yeah, the system's designed. It's often a psychological concern for us. I mean, I still have anxiety about it. Some of my engineers still have anxiety about the blast radius, but it's also something we have to take into account with any you know, any technology we're introducing into the environment that deals with you know, that has the potential to impact multiple customers. Because we're a cloud service provider, you know, we one of the approaches we take to deal with blast radius is we try to make sure that if we do have some kind of a catastrophic failure, like a triple drive failure, we have had maybe 2 of those in our the history of our company, where we lose an entire NAS all at once. That is something we also design in. Like, it's not just about the drive. We don't want to lose all of our customers at once, right? So we need to distribute our customers across multiple environments. But in some cases, our customers need a lot of contiguous space. So we're actually forced to deal with the blast radius. We're forced to increase the blast radius vulnerability because our customers are demanding bigger space. We've got many customers who now are above 40 terabyte contiguous space that they need, and we couldn't even handle those users on our old SSD based systems. And we're interested in increasing the density further, because now we're getting customers that are looking for more than 100 terabytes of contiguous space, so for their file systems. And so it is a concern of mine, but I think, you know, we need to move to more robust technology. We need to solve that. rebuild time issue. We need to keep pace with that. And we also need to, solve the blast radius issue by not putting all of our eggs in one basket with respect to, workloads. Like be able to have some workloads continue running even if there are failures in one part of our network.
Yeah, it was interesting hearing Yu Yang's discussion about, you can put now a petabyte in a 2U server now. I mean, who would have thought 5 years ago we'd have petabyte sized data sets, and that's where we're getting to. And it's
Exactly. I actually want to add one more points here. So I think the blast radius issue, it's more of an issue to HDD, to be honest, in my opinion, because HDD, the rebuild time take days, right? That's one thing. Second, over time, the hard drives, reliability or failure rate get much higher than out of box, which is a problem. But for SSDs, and especially for QLC SSD, we've been looking at the failure rate of the drive return from the field. It's been constantly lower than the target we set for our failure rate. That's very important when you think about failure, right? It's consistent over the 5 years of usage of the drive. It's consistent. It doesn't go up over time as hard drive does. So it's the data I think I saw last time is less than 0.2%, annual failure rate. So that's also significant when we think about this, blast radius issue.
That's excellent. So Tony, it sounds like the XDP card is basically body armor for the blast radius. You want to add some color to that, or is that
Sure? I think it's to answer this question specifically. It's all of it. So blast radius is caused, or concerns are caused by capacity. People don't want to put big drives in because they take longer to rebuild, and you can easily out of your control, primarily by software, but also with the wrong data protection scheme, add additional writes in the mix. And that is really what a RAID solution does, by not only going beyond what the application is doing by doing these read modified writes. So HDDs, yes, they're not really used for transactional workforces or workloads anymore. They're archival. SSDs are the primary storage for useful and meaningful applications, and they do fail. And then the other way you need to think of it is an IT operator typically is very resistive to put something new or bigger in because their job depends on it, right? So they'll try to say no to go in something bigger because they don't want to lose their jobs, but they're also under heavy pressure to get more system utilization. So there's no choice but to get more transactions out of a system, and one easy choice for that is to increase the storage size.
Excellent. Let's move to the third audience survey question. That question is, audience, what are your thoughts on deploying a data protection solution that maintains and increases workload performance, extends SSD endurance, and eliminates large drive rebuild pains? Let me launch that. And while that's out there, you should see it now. I'll give you about 2 minutes to answer. We'll go to the second panel question. And that question is, with software-defined everything being the rage these days, it seems, at least in the storage world, that the role for hardware solutions is shrinking in importance, yet a number of companies are developing these. What makes the hardware acceleration so critical for so many applications? Tom, what is, I think you talked about a lot of it, but if you want to add anything to that from your perspective?
Yeah, I guess I think our customer base again is really pushing the envelope on their performance demands. They have big data sets. They need a lot of compute. They go through this cycle where they're often importing lots of data onto our platform, and then computing on that data, producing new data, and then exporting that data. And so it's very data intensive workflow. It's encroaching on the high performance computing space. We are having to tap into the high performance computing literature in order to meet the expectations of our customers and give them tools that solve problems in this space, like AI application development and large data transformation projects. I've been not just looking at how do we upgrade our NAS environment for our VM images and customer storage, but I've been looking across the board at these storage technologies, especially to try to, create a better offering for our customers. And what I've seen is, in every case, we actually need to go closer to the hardware, because the hardware capabilities are now outstripping what can be done purely in software using generic technology. That's especially true, I think, in the storage space. We're looking at, using raw capabilities like NVMe and RAID protected NVMe through direct memory access, RDMA interfaces, and using more complex software stacks to access that underlying storage as quickly as possible. What we see is on the horizon, the next generation of NVMe is going to up the game. There's going to be, raw performance in the tens of gigabytes per second from a single NVMe device. We want to be able to give that advantage to our customers. And so, yeah, we need to design closer to the hardware instead of away from it. So
makes a lot of sense. Yang, what do you think on the matter?
I think, first of all, hard disk drive is really, it's having a lower and lower cost, but the decrease of price is not catching up with the performance, lack of performance. So I think there's more and more applications or of newer NAND technologies such as QLC or PLC, where we're continuing lowering the cost of that, and potentially in a few years we're able to cross with the cost or price of the hard disk drive while providing a better performance. So I think QLC and the following technology, the PLC, will eventually catching more and more market share. QLC, we have seen a lot of good application. Customer come to us and ask us, hey, can we have your QLC in our system? For example, in the object storage, in the CDN applications, they deploy it and they see really good performance. They achieve cost savings. They have solved problems that hard disk drive is not able to solve for them. And so that's where I see it. I see it, QLC and the higher bits per cell NAND technology will eventually taking shares from HDD.
Makes perfect sense. Tony, anything else you want to throw in before we
No, I mean, this is for those of you who know Annapurna and their history and what AWS did with that. And, it's inevitable that software can't do the job and CPUs alone can't do the job. So you need some kind of an offload engine. And in that model, they clearly took everything, all the functions for VM that had to do with networking away into the Nitro chip and allowed VMs to take full advantage of the CPU utilization. So this is many examples of that. I'm an absolute believer that the offload engines, and evidence shows that, are there to address software issues. And yes, software define everything thanks to hardware offload.
Excellent. All right, let's jump into the audience Q&A session. We've got a couple questions. So one of the questions we got is, and there's a couple people answers. We heard about what Paperspace did, what they took Pliops plus QLC. Have you seen similar similar performance improvements using NVMe drives? I guess we'll start with you, Tony, on that one first.
Can you repeat the question? Sorry.
Yeah, we talked a lot about QLC drives. I assume those are SATA drives, Tom, that you have. Do you?
No, it's
No,
only
no,
NVMe.
actually they went to, we went to.
Oh, okay,
NVMe.
okay. Well, that
Yeah.
answers that question. Then we'll
Yeah.
jump to the next question then.
Yeah, the premier QLC NVMe solution for enterprises and data center is from Solidigm today. It's unchallenged. They've had a good lead from versus other people. And their drives are thriving and getting better and bigger and better performing. And so we like those. But there's obviously, with the nature of NAND right now, with the pricing and so forth, you're seeing bigger and bigger drives, even with TLC personality.
Yeah, absolutely. Another question we got is, how many drives do I need to have in my data center to make Pliops a good investment? Is there a kind of a cliff that beyond that it's a great investment?
It depends on where you're deploying it. You are either putting Pliops and really big fat drives in a storage node, or you're putting it in the application side on the compute node. In the compute node, typically the number of drives are not as big as they are on the storage side. On the storage node, like an elastic block storage system, you want to make the node as dense as possible. So cram in as many drives as you can. Same probably with the NAS system, but that's not entirely true on the compute end. On the compute end, you are using maybe 4 or 5 drives, but even there, you're hesitant to go from, let's say, like an 8 terabyte drive to 16 terabyte to 32 terabyte. So we are seeing that people are deploying offload solutions like ours to get around that.
Excellent. There's also a couple other questions that Steve has answered. We'll put those into the transcript when we send out the results to everybody. Again, thank you very much, Tom and Yuyang, for being guests in Tony's webinar. I think we had some great discussions here, and I think looking forward to the next Pliops webinar. We'll let you know. I'll send out a link to that one as well when we send out the recording for this one.
Glad to be with everybody here. Thanks everybody for participating. Okay, bye
Bye-bye.
guys.
Bye. Thank you.